This time, we are going to verify the set of eigenvalues and eigenvectors for this given 3 by 3 matrix. Let's find out if these pairs of eigenvalues and eigenvectors satisfy or fit this given matrix here. To show, we just simply need to show this process by multiplying A, which is our matrix, to a certain vector. In this case, you have x sub 1, x sub 2, and x sub 3. Let's make this thicker. Okay. The result of this can be expressed as the product of its specific eigenvalue represented by lambda and the same eigenvector. If we could show it like that, then that means the pair satisfies the concept of being eigenvalues and eigenvectors for this given 3 by 3 matrix. So let's start by our first set of eigenvector x sub 1, and let's find out if we could actually represent it by x sub 1, lambda sub 1 times x sub 1. Okay, so our A, x sub 1, so we have our A here, 2, 3, 1, 0, negative 1, 2, 0, 0, and 3, to be multiplied with our first vector 1, 0, 0. Whatever be the result of this, if we can represent it as a product of your first eigenvalue times its same eigenvector, then that's it. We have verified the two. So here, don't forget that we are multiplying here a 3 by 3 matrix to a 3 by 1. So by concept, the result is also a 3 by 1 matrix. So we have it like this. 2 times 1 is 2. 3 times 0 is 0. 1 times 0 is 0. Adding all them up, you have 2. Next, 0 times 1 is 0. Negative 1 times 0 is also 0. 2 times 0 is also 0. So that's 0 here. And finally, 0 times 1, 0 times 0, 3 times 0, they're all 0. So this is your vector now. 2, 0, and 0. Since the eigenvalue for the first pair is 2, if we are going to factor out 2 from this matrix, you will have 1, of course that's 0, and 0. Once we did that, this is our first lambda, and surprisingly, this is our x sub 1 as well. Okay, the 1, 0, 0 here. In short, this has been verified. This pair are eigenvalues and eigenvectors for this given matrix A. So replicating the process for our next, you will have here for your A, x sub 2 must be the product of lambda sub 2 and the same x sub 2. So you have here A, which is 2, 3, 1, 0, negative 1, 2, 0, 0, 3, to be multiplied with your x sub 2, which is 1, negative 1, and 0. Again, this should, or the result of that should be, or we could be able to represent it by the product of lambda sub 2 and x sub 2 for this to be verified. So the same thing, 3 by 3 matrix times 3 by 1 will also result to 3 by 1. 2 times 1 is 2. 3 times negative 1 is negative 3. 1 times 0 is 0. So 2, negative 3 is 0. Add them up, negative 1. Next, 0 times 1 is 0. Negative 1 times negative 1 is positive 1. Then you have 2 times 0 is also 0. So you have positive 1 here. And finally, 0 times 1 is 0. 0 times negative 1 is also 0. 3 times 0 is also 0. You have here is 0. Okay? So the next thing here is to take out or factor out this lambda value or our eigenvalue here. So you have negative 1, and let's see what happens to our matrix here. Of course, if you're going to factor negative 1, that's positive 1. Negative 1 will become, positive 1 will become negative 1, and 0 will still be 0. This is our second eigenvalue paired with its corresponding second eigenvector here. So this has also been verified. Now, let's finish this with the last pair. We have 3 and then 5, 1, 2, okay? Don't forget that. So you have here a x sub 3 must be the result of multiplying lambda sub 3 and x sub 3. So you have here the same matrix. Your matrix was 2, 3, 1. It's here. We can see it here. 2, 3, 1, 0, negative 1, 2, 0, 0, 3. And our third vector is 5, 1, and 2. You have 5, 1, and 2. The result of this should be the product of your lambda sub 3 times your same vector sub 3. So this is, okay, let's start. Again, 3 by 3 times 3 by 1 will have this form. So you have 2 times 5 is 10. 3 times 1 is 3, that's 13. 1 times 2 is 2, so that's 15. Positive 15. Then, 0 times 5 is 0. Negative 1 times 1 is negative 1. 2 times 2 is 4. Negative 1 and 4, you will have you will have positive 3. And finally, 0 times 5 is 0. 0 times 1 is 0. 3 times 2 is 6. So that's 6 here. This is the result for this expression. And since our third eigenvector is 3, 3, let's see if this could be the result of the remaining matrix. When we factor out here 3, 15 will become 5, 3 will become 1, 6 will become 2. This is our third eigenvector, and this is actually, eigenvalue, and this is actually our third eigenvector, 5, 1, and 2. Same thing, we have satisfied this. So even if it's a 3 by 3 matrix, the same thing will follow. We need to satisfy this idea to show that the pair of lambda value and the vector are considered to be eigenvalues and eigenvectors of the given 3 by 3 matrix. So this is how we verify eigenvalues and eigenvectors for a 3 by 3 matrix. Thank you very much for watching.